Self-control. All right, so grab your gravity calculator. We'll get to those in a little bit so we can get going. Here we go. So let us refresh ourselves with Kramer's rule. Now, again, just like I told you yesterday, don't memorize all the parts. Memorize the pattern. Okay? The pattern, again, is that the denominators are the x and y coefficients. Okay? So those are the x and y coefficients in that order. Then, if I am solving for x, I am going to replace the x coefficients with my numbers. If I'm solving for y, I'm going to replace my y coefficients. If this were a 3 by 3 system of equations, I could replace my z coefficients with the numbers and solve for z. Again, it doesn't matter what the system is as long as you know the pattern. Denominator is the coefficients of the variables. Replace whichever variable you're solving for, that column, replace them on top. Okay? So, I would like you to use Kramer's rule here to solve this system of equations. Yes. All right. So, if I'm going to solve for x, my denominator is going to be 6, -2, -2, and 3. My numerator, because I'm solving for x, the -2 and the 3 for the y coefficients stay, but the other ones become -2 and +10. Crisscross applesauce. Okay? Criss minus cross makes you want to jump. Okay? So that's going to be -2 times 3 minus 10 times -2. All over 6 times 3 minus -2 times -2. So that's going to be -6 plus 20 all over 18 minus 4, which is going to be 14 over 14. So x here equals 1. Now, I could just say, because I got a 2 by 2 system, x equals 1, plug in an x in one of my equations and solve for y. Okay? I could do that. That's legit. Okay? If I wanted to use Kramer's rule to solve for y, though, then that would be y equals something over 14. This time I keep my x coefficients and I replace my y coefficients with that. So then this becomes 6 times 10 minus -2 times -2 all over 14, which is going to be 60 minus 4 all over 14, which is 56 over 14. So then y here is equal to 4. So my suspected answer then is the point 1, 4. 6 times 1 is 1. 2 times 4 is 8. 6 minus 8 is -2. It checks out in the first one. -2 times +1 is -2. 3 times 4 is 12. -2 plus 12 is +10. Checks out in the second one. Yes, ma'am. just said that was legal, yes.
No, but I said on test, will you ever just have to?
I just said that that was legal, yes.
Yeah, we will.
So yes, you can do that.
No, okay, will you ever like make them do? Alright, that was my question.
Yes, you can do that.
Okay.
So, again, the pattern is the same. The pattern is the same. Okay? So if I'm solving for x using Cosmo-Kramer's rule, my denominator is going to be 6, -2, and 2, -2, 3, and 1, -6, 1, and -5. If I am solving for x, then my numerator is going to have the x coefficients replaced with -8, 10, and -2. Now, just for practice, I would like to do one of them top or bottom with the calculator and one of them top or bottom by hand. You be the pickers, I'll be the grinner. That's what hee-haw. Hee-haw. The show, it was a variety show back in the 70s.
Oh, that wasn't born.
I know. Really? So you want to pick top or bottom? Top to do by hand or by calculator? Calculator? Okay. All right. So then let's do the bottom first by hand. Okay. So then that's going to be 6 and -2, -2 and 3, -6 and +1. I've got 3 Chris's. That I need to multiply together. So that's going to be 6 times 3 is 18 times -5 is -90. Plus -2 times 1 times -6 is +12. Plus 2 times -2 times 1 is -4. Then I've got 3 crosses. Oops. Oops. Kind of went right through my -5. 1, 2. That's okay. So there's 1. There's 2. There's 3. All right. So then that's going to be minus -36 minus 6 minus -20. Right? So -90 plus 12 is 72. -78, excuse me. -78 minus 4 is -82. Plus 56 plus 50, so that's going to be 32. -32. Right? Check me on that. -90 plus 12 minus 4 plus 36 minus 6 plus 20. Should be negative 32. Yes? Okay. Now my numerator, we said we wanted to do using the calculator. Yes? Okay. So I'm going to need to have a calculator page open. I'm going to go DET of my 3 by 3 matrix. And then I'm going to go negative 8 and negative 2 and 2 and 10 and 3 and 1 and negative 2 and 1 and negative 5. And that gives me 64.
What?
Is a negative sign somewhere?
I do something, so I got 24.
Okay.
Yes. Wait, okay, negative 8.
I'll read them off left to right. Ready? Negative 8, negative 2, 2.
Yep.
10, 3, 1.
Yep.
Negative 2, 1, negative 5.
I had a positive 5.
Yep, that'll do it. Okay. So my numerator here then is 64. That gives me an x value of negative 2. Yes? Okay. Now we've got to solve for y. I know that it's going to be over negative 32. Six, negative 2, and negative 6. 2, 1, and negative 5. But now I replace my y coefficients with negative 8, 10, and negative 2. Calculator or by hand? Make it happen. I get negative 32 for my numerator. Which means y is equal to 1. Okay? Now again, I could go on and I could do that same process for z, or I could go back up here and I could say in this equation, negative 2 times negative 2 plus 3 times 1 plus z equals 10. So that would be 4 plus 3 plus z is 10, which is 7 plus z is 10. So z is 3. So my suspected answer then is negative 2, 1, and 3. 6 times negative 2 is negative 12, minus 2 times 1 is negative 14, plus 2 times 3, so that's 6, so negative 14 plus 6 is negative 8. Checks out in the first one. Negative 2 times negative 2 is positive 4. 3 times 1 is 3. 4 plus 3 is 7. Plus 3 is 10. Checks out in the second one. Negative 6 times negative 2 is positive 12. Plus 1 is 13. Minus 5 times 3. 5 times 3 is 15. 13 minus 15 is negative 2. Yahoo for school. Okay. The last topic that we need to talk with Kramer's rule is our special situations. These are the exact same special situations that we did in substitution and elimination. Back then, we said that in situation number 1, this was a no solution case. In situation number 2, we said this was an infinite solutions case. With Cramer's rule, it becomes a little tricky. Okay? So if I set up here my x equals Cramer's rule, 3, -6, -6, and 12, and then I set up my 14, -6, -16, and positive 12 one there. If I do this math, that's going to give me 14 times 12 is 168 minus -16 times -6 is positive 96 all over 3 times 12 is 36 minus 6 times 6 is 36. Does anybody see an issue? The denominator is 0. So here we would get that x is equal to 72 over 0. Okay? So in this particular case, you are looking for your denominator to be 0 and your numerator to not, let's go this way. You're looking for your numerator to not be 0. Okay, to be some number. So you're basically looking for some number over 0. If you get that, that is the no solutions case for Cramer's rule. Okay. Fast forward to situation number 2. Again, if I solve for x, I got 2, -4, -2, and 4. I've got that. 13 times 4 is 52, minus -13 times -4 is 52. 2 times 4 is 8. -2 times -4 is 8. What's wrong with this one? It's not going to equal 0. They're both 0. Both the numerator and the denominator are 0. Everything cancels out. Okay? Okay. So Cramer's rule is a 0 over 0 that gives me infinite solutions case. Number over 0, that's no solutions. Okay. Handle? Again, same homework as yesterday. Again, I ask that you do the first, what did I say yesterday, 6 problems or so?
Yeah, all of those
By hand. If you want to use a calculator on the last 4 problems, that's fine. Okay. But the first 6 are done by hand. I also remind you that this is due on Monday. I also remind you that there is a formative tomorrow. What's up?